Hello. In this topic, we're going to look at something called binomial expansion. That's expanding a bracket, say this, x plus y to the power of n for any power n. And so in this topic, we're going to look at more efficient and quicker, better ways of expanding brackets, right? Instead of just having to expand them, like this, and we could have many brackets. We could have, say, x plus y to the power of 10 or something like that. Um, and so we're going to look at ways of doing that more quickly and actually spotting perhaps, say, a certain coefficient as well, rather than just have to expand it all. And that will take a long while. And we've already seen certain questions, particularly when we looked at circles with tangents and you have to substitute stuff into the circle. You get nasty brackets to expand. So that's what this section does. And so what we're going to do, we're going to start off by looking at something called Pascal's triangle. In itself, it doesn't get. They don't really ask exam wise about it, but it's a building block towards topics later on in the section, which will be important. Okay, let me write down these numbers. So we have 1, then we have 1, 1, then we have 1, 2, 1, we have 1, 3, 3, 1. Okay, why am I writing this? Well, this is Pascal's triangle, because the numbers, well, they're kind of like a form of triangle, right? And there's a pattern to it. Now the pattern is where we start with these ones on the top. Basically, we put ones on the diagonals, right? The outside diagonal here. That's kind of like the side of a triangle, right? So the outer edge or the outer numbers have to be ones. Then the numbers inside, we deduce these numbers by looking at the two numbers above it. So look at this 2 here. There's a 1 here and a 1 here to the left and right on top of it. What we do then is just add those two numbers. So 1 and 1 gets us 2. So we look at the number for any number in between the ones. We look at the numbers on top of it to the left and the right, and we add them together. Okay, what about this 3 here? Well, this 3 again, the top left and the top right of it, it's 1 and 2. Then we add them to get 3. That's where we get 3 from. Same way here, this 3 again, to the left it's 2, to the right is 1. So we add them together and we get 3. Then we can continue and go even further downwards. So again, we have 1 out here and 1 out here. Now, what about this number then? This number, well, think about 1 and 3. If we add them, we get 4. So that would be a 4 there. Then what about this number in between 3 and 3? That would be 6, right, if we add them. What about 3 and 1? That will get me 4. And again, I can go on. It's a bit there we are. And then we can go again. So we have 1 here, 1 there. So then 1 and 4 now get me 5 here. And then the next number in between will be 10. In between 6 and 4 will be 10. In between 4 and 1 will be 5. And one more row. Again, we have 1 out here, 1 outside again. So then inside is going to be 1 and 5 here. In between will get me 6. In between 5 and 10 will then get me 15. In between 10 and 10 will get me 20. In between 10 and 5 will be 15. 5 and 1, 6. And there we are. So we add the two numbers and get the number in between, right? As we go down the triangle, we add two numbers together between each other to get the number below, right? In this manner. And this goes on forever, right? This triangle will repeat forever. But we call this Pascal's triangle. So hopefully you get the idea of how we construct this triangle. How we go from the top to the bottom by just adding two consecutive numbers together in the row. to get the numbers below it. Now, so why is that important? Why are we just coming up with this triangle? Well, it relates to what I talked about with binomial expansion. What these numbers actually end up doing is give us the coefficients of all the terms if we were to expand x plus, say, a to the power n, right? So if we expanded that, obviously we would expect how many n plus 1 terms. So all of those terms, if we were to expand it, that gets us the all the terms, right? But what does that mean exactly? Because without any examples, it's a bit confusing what I said there. Let me have a look. So let's say we have x plus 1, right, to the power 2, all squared. Now normally you could expand that, right, like this, and then you expand the two brackets. However, we're going to use this pyramid instead, or triangle. And so, how we use this then? We start from the top. Now that's row. We call that row 0, right? We start from 0. I'll explain more in a minute. But we start from 0 instead of 1, which might be a bit weird, but yeah. Then we go to row 1. There, and row 2 will be the next one there, and so the row number here, 210, that corresponds to the bracket number, the exponent, the degree, right, 2. That then tells us then that we'd be looking for row 2, okay? So we have 2 in the bracket there, the power is 2 in the bracket. So we want to look for row 2. So we want to look at these numbers here. Then that tells us the coefficients of each term if we were to expand it, right? And so, with that in mind, the terms we're going to get, firstly, well, you're going to get, it's squared, right? You're going to get a quadratic term. So it's going to be x squared. But then the first number is 1, so then that would be 1, x squared. But if that's x squared, then we also say the other number 1 here would then have a power of 0, right? Again, it might seem a bit weird at the moment, but once we go through examples, hopefully pick up what's going on here. Okay. So again, that's the first, because that's the first term, the x squared, right? And we're going to go from x squared to x, and then there'll be no x term, right? So x squared is first, so therefore we pick the first number in row 2. That 1 that I've boxed in would be the coefficient there, the coefficient of that term. Right, then we move on to the x term. So with x squared, then we have x. So it's going to be x. The next number then is 2. So the next term I have a coefficient of 2. So it'd be 2x. And then be times by 1, the number with x there. So we have to consider both the x and the number in the bracket, right? So the 1. And that would be to the power of 1 now, right? The idea is that the powers of the x and the constant, or whatever else we have, in this case 2 and 0, it should always add again to the exponent in the bracket. So we have 2 and 0, that will add to get us 2. Now for this part, the x term, the power of x is 1, right? There's a secret 1. Then we have 1, and then we have this power 1. That will add to get me 2, which is there, okay? And then our last term, well, there'll be no x term, right? It's like a quadratic, right? Ax squared plus bx plus c. That's what we expect. So we have the x squared term first, the x term, and then this number at the end with no x. Now, if that's no x at the end, that's just x to the 0, right? And so the coefficient then, via this triangle, is now 1. Okay, that's the last number in this row. So the coefficient be 1, and then we also have this 1 here, And so that would be 1 raised to the other. Well, if it's 0 for x here, then it's going to be 2. To then ensure we match the exponent of 2. Right, and that's our expansion. We can then simplify it by just simply timesing all the brackets together. Well, 1x squared of 1, that's just x squared. Then we have 2 times x times 1, that would be plus 2x. And 1 times x to the 0, which is just 1. Remember the index law. X to the 0 is always equal to 1 for every value of x. That's an index law. So that's 2 times 0, 1 times 0, 1 times 1 times 1. So that's just plus 1. And so there we are. That's the triangle gives us the expansion of the bracket. You can check that bracket. Again, we'll do it here. If we were to expand it the other way. Now, that would be x squared. Add x, add 1. Well, that just goes to 2x, right? And there we are. Now, obviously, that is a lot quicker than how we just did it. But A, I'm explaining it. But B, this method really shines with larger brackets, right? It will be more efficient and for longer powers of x. Okay, so that's one example. I'm going to pick another one. I think it's best to learn this through examples. So we have, let's say we have x take away 2. And that's cubed now. So if we were to expand that. Now normally you'd do 3 brackets and then times them together one by one. But instead we're going to use this triangle. Now the power is 3. Which means we want to look at the third row. Now remember when we start, because we start from 0 with the rows, this is row 2. So then row 3 would be the number of the row below it, there. And so we want that row 3, because that's the power. So that's telling us the degree, right? So we are interested in these numbers here. And again, that will give me the coefficients of the terms of each term of x, right? So again, this is going to be a cubic. So firstly, we're going to have x cubed. So the coefficient then for x cubed, well, it's going to come from this row. But the first number's 1. So that will be 1 as the coefficient. And then we have x cubed, so then the other number minus 2 then be times by minus 2. That will then be to the power of 0, right? Because then 3 adds 0 gets us 3, which is the bracket power. There we are. Right, and then we've got the x squared term, right, next. And so the idea is essentially we're going to go descending powers of x. With this thing, so we get x cubed, then we have x squared, then we're going to have x, and then we're just going to have no x, right? That's the idea. So that's x squared. Now that's going to be because that's the second term in our sort of expansion. We have x cubed first, then we have x squared. So it's going to be the second number, so it's going to be a 3. So the coefficient this time is going to be 3x squared. And again, then we need to factor in this minus 2 as well. So then that would be times by minus 2 to the power of 1. Because then 2 and 1 gets us 3. We want the powers to be 3 now, remember? Because that will coincide with the power of the bracket. Okay, and then we have the x term. So it's going to be x. Then the coefficient, in that case, will correspond to the third number in the row, which is there. So that will be a 3. And then we have this minus 2 to deal with. And so that minus 2 will then have to be squared, right? Because again, this x is a power of 1. 1 and 2 gets me 3 in that case, okay? And then lastly, we have no x, so it's going to be x to the 0. So the final term, so the final number in the row will be 1. That's the coefficient here. So that's 1x to the 0. And then minus 2 will then have to be cubed. Because 0, we need to get 3 from the 2 powers. 0 and 3 indeed gets us 3. Okay, well then we can just then we can sort of expand the brackets and simplify it. Well, 1x cubed minus 2 to the 0, again that would just be 1. So simply we get x cubed. Then we have 3x squared times minus 2. So that'd be minus 6x squared. Then we have 3x times minus 2 squared. That should be a squared there, apologies. So minus 2 squared is 4. So 4 times 3 would be 12. So we get 12x. Then we have lastly here 1 times x to the 0, which is 1. 1 times minus 2 cubed, that's minus 8. And there we are. So hopefully you can start to spot now, once you get used to it, it is going to be quicker than expanding like a triple bracket, say. And once you get to powers of 4 or 5 or higher, it becomes far superior. Okay, I'm going to try one more example before we look at the actual examples with using this. We have, I'm going to say 2x minus 3 to the power of 3 again, okay? So that means, firstly, because it's power 3, we want to look at row 3 in our triangle, which again is going to be the same row that I've boxed in. So row 3 will be here, there. Remembering again, we start from 0 at row 0. I'll talk about that after this, actually. I did say I was going to explain why. But yeah, that'd be row 3. So those are the 4 numbers we're interested in: 1, 3, 3, and 1. That'll tell us the respective coefficients of each term again. So if we were to expand this, then firstly we got the x cubed term. So that'd be, well, x cubed. However, we don't have an x now. We have 2x. So instead of x, it's simply 2x then, all cubed. Okay, then the coefficient of that will be 1, because again, 1 is the first number here, because this is the first term we're dealing with in our expansion. And then we got to deal with the minus 3 as well. And so that would be to the power of 0, because 3 and 0 is 3. Okay, then we have the x squared part. Well, it's not going to be x squared, it's going to be 2x all squared, because we have 2x now, not x. Then we have the coefficient to consider. So the second term, the coefficient will be 3. That's the second term in a row. So we have 3, and then we have to deal with this minus 3 as well. So the power of that will then be 1. To get 2 and 1 is 3. To again match the power in the bracket. Okay, then we have the x part. So instead of x, it would be 2x to the power 1. Then we have the coefficient. Again, that'll be 3, because that's the third term here. And then the power of minus 3 again. And then the power of that would have to be 2. Because then 1 and 2 is again getting us 3. And so lastly, we then have no x, right? So it'd be 2x to the 0. And then the power of that would be, the coefficient would be 1, right? That's the last term, 1, 2x is 0. And then the minus 3 would then have to be cubed to then get 3, and 0 gets us 3. Okay, there we are. So then if we simplify, do the brackets. Well, minus 3 to the 0 here would just be 1. So simply left with 2x all cubed. Now we can expand that, because 2 cubed is 8. So that would be 8x cubed. Then we have 3, lots of 2x all squared times minus 3. Well, firstly, 3 times minus 3 is minus 9. And that would be lots of 2x all squared. I'm not going to expand it just yet. I'll do it after. Okay, but then we have this 2x to the 1. So then we have plus 2x to the 1. Now 2x to the 1 is just 2x, right? And then it's 3 times minus 3 squared. Well, minus 3 squared is 9. Then 9 times 3 is 27. So we have 27 lots of 2x. Then lastly we have 2x to the 0, well, that's just 1. So effectively we have 1 times minus 3 cubed. Well, minus 3 cubed is minus 27. And there we are. And so if we were just to quickly expand these last two brackets here, well, 8x cubed and minus 9 times 2x all squared. 2 squared is 4, so 4 times minus 9 is minus 36, and that'd be x squared. Then we have 27 times 2, which should be 54. So we get 54 lots of x, and minus 27, and there we are. Okay, so expanded it there. Okay, so these brackets, these triangles do give us the coefficients that we need to expand brackets, and using it in this way will be gives us a more efficient way of doing it. Okay, now before we look at examples, why we start from row 0, not row 1? Well, it's because of the fact that hopefully you've noticed we have these zeros as well in our x to the 0, of minus 2 to the 0 there. We include powers of 0, right, in our expansion. Again, if you look at here, we end with 2x to the 0, right? And we have minus 3 to the 0. So we include powers of 0 in our expansion. And more to the point, row 0, say if you have x plus a, we could also have x plus a to the power of 0, right? Now that's just 1. Well, actually, there we are. So it kicks us off with 1. So what row 0 tells us is, because in our expansions, we have to include powers of 0 in our answer. Because, for example, say for quadratic, right? We have this plus c, again to remind you. That plus c is actually technically c, some number c, times x to the 0. Which, obviously, x to the 0 go to 1. But it really, technically, we do end polynomials with a degree of 0. So actually, because of this, we do have powers of 0. So we have to start from row 0, okay? Because the row number, again, corresponds to the degree of, say, a bracket, right? So we don't start from row 1. We start from row 0, okay? Because of the fact we can have powers that of 0 in our expansion, right? So yeah. So when you use the Pascal's triangle, very important to remember you start from 0 when you look at the rows, okay? And then you go from there. Okay, so let's have a look at some examples then. First of all, use Pascal's triangle to find the expansions of x plus 2y cubed. Now again, so cubed, we're going to want row, well, we want the fourth row, or row 3. So let's write, so with these sort of questions, we're going to need to fill in the first few rows of Pascal's triangle. Start from 1, then we have 1, 1. Then we go from 1 and 1 here. Now the number in between here will then be 2, because then 1 and 1 here gets us 2. So then that'll be row 2. Because this will be row 1, and that'll be row 0, right? Then the third row, we want the third row, because that's the power we've got, okay? So the third row will then be 1, and then 1 and 2 will be 3, 2 and 1 will be 3, and then we get 1 at the end. So that is the row we're interested in, because we have a power of 3. So that will again tell us the coefficients of the terms we expand. So now to expand it itself, well, firstly we're going to start with x cubed. That'd be the first term. So then the coefficient then, the first number is 1. So there we are. So 1x cubed, then we're going to be timesing it by 2y, the other number, right? Because again, with these brackets x plus a, we have we have two numbers added together. That's how we expand it, right? So we have to include both the x and the a, or the other term. In this case, we have 2y. But anyway, so we have x cubed. So then the other term 2y, that would then have to be a power of 0. Again, it has a power of 0, hence why we must include a row 0. Anyway, so there we are. Then we move on to the next term, that's the x squared. Then so the second number in the row would be 3. So that's 3 there. And then we have the 2y to consider. So the power of that would have to be 1. Because then 2 and 1 gets us 3. Okay. And then we have the x term. So again, the third term then, because that's the third term in our expansion. First term there, second term here. This is the third part. So the third number is 3 again, and then that'd be power of 1. So then the 2y then, it needs to be a power of 2. Because then 1 and 2 gets me 3. Because hopefully again you're noticing all the exponents are adding to 3 to match the power here. Then lastly we have plus x to the 0. And then the coefficient, the last term is 1 here. So there we are. And then the 2y term has to be a power of 3 to give us the overall degree of 3. But then we just simplify the brackets, okay? So then we have 2y to the 0 is just 1, because that's just something to the power of 0. So then simply we get x cubed. Then we have 3x squared times 2y. Now that would be 6xy, or x squared y. Because 3x squared times 2 would be 6x squared times y. That'd be 6x squared y. Okay, then we have 3x. Now this is raised to the power of, and then 2y is raised to the power of 2. So if we expand that, that'd be 4y squared. So we just leave it there. We'll expand that after, but yeah. Okay, then the last term we have 1x to the 0, and that's just 1 again. So we're simply left with 2y cubed. Now if we expand that, 2 cubed is 8. So we get 8y cubed. So then we simplify any brackets left. We get x cubed plus 6x squared y. Add 3x times 4y squared, that'd be 12xy squared. Add 8y cubed. And there we are. Cool. So that's part A. Part B then says find the expansion of 2x minus 5 cubed, was it? To the power of 4. Okay. So we can reuse our Pascal's triangle we did already. So it was 1, 1, 1. Then it was 1, 2, 1. Then 1, 3, 3, 1. But that'd be row 3. If we start from 0, 0, 1, 2, that'd be row 3. However, the power now is 4. So we need row 4. So we need to do another row. So it'd be 1 here and 1 there. Then if we start to fill in this row, 1 and 3 will then get us 4 here. 3 and 3 gets us 6. 3 and 1 gets 4. And there we are. So row 4 then, this is the row we're interested in this case. This will give us the coefficients of this expansion. So, then we expand it. I'm probably going to do it here. Firstly, we're going to have this x. We're going to have the x to the 4 term. But it's not just x, it's 2x, right, this time. So it'd be 2x all to the power of 4. Then the coefficient, because it's the first term, it'd be 1. There we are. Then we have this minus 5 as well. Now that would be to the power of 0, because then 4 and 0 is 4. Because again, we still need to match the power here. Then we have the x cubed term, but again, it's not x, it's just 2x now, all cubed. Then we have the next term in the row, which is 4, so that'd be 4 there. Then we have the minus 5 part. Now that'd be to the power of 1, because then 3 and 1 is 4. Then we have, well, the next term will be 6. Then we're going to have 2x, again to the power 2 now, because we're potentially knocking off a power of the power each time, right? There we are. So we're going from 4 to 3 to 2. Then we have minus 5, that'll be then to the power of 2 as well, because then 2 and 2 gets us 4. So then we're going to have 4 for the next coefficient. And so then that'd be 2x to now to the power of 1, because we've gone from x to the 4, 3, 2, and then 1. Then we're going to have minus 5 cubed, because then 1 and 3 is 4. And then lastly, the last term, the coefficient is 1. And then we have 2x to the 0. And then we're going to have minus 5 to the power of 4 here, right? As then to give us an overall degree of 4. But there we are. So then we just need to simplify the brackets. So here, the first term, well, minus 5 to the 0 is just 1. So effectively, we just got 2x to the 4. 2 to the 4 is 16. so 16x to the 4. Then for the next term here, we have 2x cubed minus 5. So firstly, minus 5 times 4 is minus 20. So minus 20 lots of 2x cubed. We'll expand that in a minute. I try not to do everything at once. Well, you can do, but for now, to keep it, we'll do it one by one. Okay, then we have this next term. So we have 6 of 2x squared, but then minus 5 squared as well. Minus 5 squared is 25. So then 25 times the 6 is 150. So we have 150 of 2x squared. Then the next term would be 4 of 2x to the 1 minus 5 cubed. Now minus 5 cubed is minus 125. Minus 125 times 4 would be minus 500. So minus 500 of 2x. Now 2x to the 1 is just 2x, right? Then lastly we have this term at the end. Now 2x to the 0 will be 1 again. So effectively we just got minus 5 to the 4. Put that in the calculator, say we get plus 625. So then we just simplify any remaining brackets. So we get 16 x to the 4 minus, we have 20 lots of 2x cubed. Now 2 cubed, if we were to expand that, is going to be 8x cubed. So then 8 times minus 20 is minus 160 x cubed. Then we got 150 times 2x squared. Now 2x squared is 4x squared. So 4 times 150 is 600. And then 600x squared. Then we have minus 500 times 2x, and that'd be 1000x. And then we have plus 625. There we are. So that's our full expansion. Cool. Now, if you did 4 brackets, that would take longer, let's just say. But there we are. Let's have a look at this example then. Okay, we're told now the coefficient of x squared in the expansion of 2 minus cx cubed. Obviously c is just a number, it's a constant. The coefficient of x squared here is 294. Find the possible values of c. So this is kind of a bit more problem solving. We need to be a bit more mindful about our expansion, because this time it's not telling you to do the full expansion. It's only looking for a particular term, a particular coefficient of x squared, right? So we don't need to do the full thing. You could do the full thing, but we can be a bit clever and save some time here. So hopefully you get an idea now for how we can use the expansion. But now we can be a bit clever with it, because again, we're still going to need Pascal's triangles, because we're still going to need the coefficients the triangle gives us. Now, the bracket number is 3, so we want row 3 from the triangle. So if we do the first few rows again, it's going to be 1, 1, 1, and then 1 outside. So remember, the key idea is 1s are going to be on the outer parts of the triangle. Then inside, well, 1 and 1 gets us 2. And then the next term after will be 1, 1, and then 1 and 2 gets us 3. And 2 and 1 here gets us 3 as well. Now that would be, well, that's row 0. That'd be row 1. That'd be row 2. Now this will be row 3. And that's what we want, because we have a cubed here, a power. So this is the row we want. So that'll tell us our coefficients. Now, usually we go x cubed first, then we go to x squared, right? Remember? X cubed, we start with the highest power first, I should say. We start with the highest power first, and then that'd be x cubed, right? Because then that'd be x, the power is 3, so there we are. So then after x cubed would be x squared. So again, we knock off a power of 1 each time as we go along term by term. But we want x squared only here, right? So we don't want x cubed, we want the x squared term, the term after. That would be the second term then. So the second term is x squared. That means then we want the second coefficient in the row. So that'd be 3. However, the answer then would not be C, is 3. Because remember, we don't just have x now, we also have minus cx. So then we have minus cx, and then that'll be squared, because that would be the second term. So that'd be 2 here. And then we have the 2 to think about as well, because we're adding 2. And then that'll be a power of 1, because then 2 and 1 gets us 3. To match the 3 here. Okay. Hopefully you can spot what we've done there, right? We've only we only used one particular term in the expansion. We didn't do the full expansion. We cottoned on to the fact, well, x squared, well, the highest power will be x cubed, because it's a 3, but we want x squared, so that'd be the second term, right? And so that corresponds to the 3, the second term in that row here. And so then we use the expansion here. Okay, well then we can simplify this bracket, right? Well, firstly, minus cx all squared, that would be c squared x squared. Then we have 3 times 2, right? So that'd be 6. So that goes to 6 c squared x squared, and so there we are. So that is the full term of x squared now. Now, it said the coefficient of x squared in this expansion be given as 294. So actually, it should be 294x squared. But we have here 6c squared x squared. Well, therefore then, if we then compare the coefficients on the both sides, we can deduce 294 is 6c squared. So then we need to solve for c, because it told us to find the values of c. So firstly, c squared divided by 6 to both sides. 294 divided by 6 is 49. Then c is going to be plus or minus root 49. Now root 49 is just 7. So therefore our two values are c 7 or c is minus 7. It didn't tell us anything else about c yet. The possible values, so there we are. So that's our answer. So hopefully you can kind of get your head around what we've done there. Questions will tend to ask you questions like this. They might ask you to find a particular coefficient instead of the whole expansion. If it does help, you can find the whole expansion. You can do that if you feel comfortable. It depends on the power though. Sometimes they give you an absurdly high power. But in this case, it's not too bad. It's just cubed. But hopefully you see the idea that we only extract a certain term that we want. In this case, we only wanted to consider the x squared term. Now we have x. The highest term would be x cubed because it's 3 here. X cubed would be the first term. Then x squared, if we go down by 1, it'd be the second. So then again, that we only consider the second term here, and so there we are. So and then we just follow the normal procedure. But there we are. Okay. So have a look at some exam questions then. So first of all, it's asking us to expand 2 and y cubed. Then it says this other part, but we need to do this part first. So we have 2 and y cubed. So we need to expand. Now, it doesn't say how you can expand. You could do it bracket by bracket, the sort of the GCSE way, or how we did it before. But obviously, let's try and use the binomial, the Pascal's triangle, right? That way. So a Pascal's triangle will be 1 here, then 1 1. If you do the first few rows, right, then we have 1 2 1. Then we have 1 3 3 1. And actually, we don't need to go any further because we want row 3 because the power is 3. Now that would be row 3. Because remember, we start from row 0, that'd be up here. Row 1's there, row 2 is there, so that'd be the third row. So we're interested in these numbers in particular. They will tell us information about the coefficients, okay? So then if we go about our expanding, well, firstly, I'm going to do y first. So that'd be y cubed, the highest power of y cubed. That would be the first term. And because that's the first term, we want the first number here, which should be 1. So that would be the coefficient outside there. And we also have this 2. So then it would be 2, but that would be to the power of 0. There we are, because then 3 and 0 is 3. Okay, and for the next term, well, the next term in the row is 3. So then we have 3 for the coefficient. Then we're going to have y squared now. Then we're going to have for the 2, well, that's going to be 2, well, to the power of 1, right? Because then we go 2 and 1 gets us the 3. Oh, no, the 3 there, right? And there we are. So then the next term will be just y, but then the next coefficient will be 3. So go 3 again and y. And then for the 2 here in the bracket, it's going to be 2 squared now, 2. Because this is a power of 1, 1 and 2 gets us 3. Then lastly we have a y to the 0 term, and the coefficient will be 1, the last term in the row. And then the 2 will be cubed, because then we get an overall power of 3. So there we are. If we were then to simplify the brackets, well, here, the first term here is y cubed. 2 to the 0 is again just 1, because anything to the 0 is 1. So we're just left with y cubed here. Then for the next term, we have 3 times y squared times 2. Well, 3 times 2 is 6. So we have plus 6y squared there. Then the next term is 3y to the 1, 2 squared. So that's y. And then 2 squared is 4. 4 times 3 is 12. So we get 12y there. And then lastly, we have 1 times y to the 0 times 2 cubed. Well, y to the 0 again just 1. So then 2 cubed is 8. So we get plus 8 there. Cool. So that's the first part. Then it said we need to write down the expansion of this bracket. 2 plus x minus x squared to the power of 3 in ascending powers of x. So we need to expand this now. However, the command word says hence. That means you need to use your previous answer, so your previous working. So we looked at expanding 2 plus y cubed here, and that's the expansion we got there, right? But now we have 2 plus x plus minus x squared cubed. Well, hopefully you can, the power is the same, the 3, the bracket's 3. We have 2 plus y here inside, but now we have 2 plus x minus x squared. But hopefully you compare, if we then said y is x minus x squared, they're the same. I can then, if I say y is this, these are the same brackets, right? Because as you can see, the plus y corresponds to the plus x minus x squared. Everything else is the same, right? Bracket wise. So what we can just do is, instead of just expanding this by its own right, can't we just use this y expression here, this substitution? Can't I substitute this y into here? And because I've already got the expansion in terms of y here, so I kind of substitute that in to get this bracket here without doing much work, right? If I do that then that will equal, well, y cubed will be x minus x squared all cubed. Then we have 6y squared, that's 6 lots of x minus x squared all squared. Then 12y will be 12 lots of x minus x squared plus 8. And so effectively then we just need to simplify these easier brackets, right? Here we had plus 2, but the brackets are a lot easier now because it's just x minus x squared. Less terms in the bracket makes it easier to deal with. Now, I could, well, I need to expand these brackets, right? I could, again, maybe use Pascal's, but two things. First of, well, you could, obviously, nobody's stopping you, but it'd just be a bit more work because here, the power is 2, and here the power is 3. They're different powers, which means we'd need to use row 2 and 3. We need to use 2 rows in the triangle, which creates 2 different brackets to consider. So that might create more work, but also we could just expand it manually in this particular case, because if I said, well, x minus x squared cubed, that's just x minus x squared times by itself 3 times. But during this expansion, if I expand these 2 brackets, that's squared. So actually, if I work out the first 2 brackets, I get this expression squared, and then if I work out all 3 brackets, then I get this cubed, right? The cubed here, right? So I'm kind of knocking 2 birds out with 1 stone, with one expansion giving me both the brackets that I want, the squared bracket and then the cubed, because I times by the bracket 3 times. So I'm going to do it this way instead. So firstly, if I expand these two brackets, well, firstly, this will be x minus, hang on, let me just expand it. So if I do that then, well, firstly, x times x will be x squared, then x times minus x squared will be minus x cubed. Then we have x minus x squared times x, that'll be minus x cubed. Minus x squared times minus x squared is plus x to the 4, times by x minus x squared. We can simplify that bracket then. If we collect the x cubed terms, we get x squared, take away 2x cubed, add x to the 4, times by the x minus x squared. Now this, this is x minus x squared squared, right? So I can substitute that into here after I'm finished, right? Into that bracket there, right? But anyway, then if I expand these two brackets, so firstly x squared times x will be x cubed. Then x squared times minus x squared will be minus x to the 4. Then we have minus 2x cubed times x, that would be minus 2x to the 4. Then minus 2x cubed times minus x squared would be plus 2x to the 5. Then we have minus 2x cubed, then we have x to the 4 times x is x to the 5. Then x to the 4 times minus x squared is minus x to the 6. And then I can just simplify the terms again. So we have x cubed, then minus x to the 4 minus 2x to the 4 is minus 3x to the 4. Then 2x to the 5 and x to the 5 is plus 3x to the 5. And we have minus x to the 6. And that is the bracket cubed, right? That's x minus x squared. All to the power of 3. So I can substitute that result in, and again, this bracket squared, right, the thing I've highlighted, underlined there, into this expression here. So therefore, 2 minus x squared, I need to make a bit more room than that. Therefore, 2 plus x minus x squared to the cubed is x minus x squared cubed, which is this, right? X cubed minus 3x to the 4 plus 3x to the 5 minus x to the 6. Then we have, so I'm looking at this, right? So then we have 6 of x minus x squared squared. Now the squared bracket is again this there. So that'd be 6 lots of x squared minus 2x cubed, add x to the 4, is it? Yes, there we are. Then we have up here plus 12 of x minus x squared. Then we have plus 8 on the end. So there we are. So now we just need to expand this. There we are. So again, to remember, that is 2 plus x minus x squared cubed. And there we are. So we get to this point. So if we expand the brackets, we get x cubed minus 3x to the 4 plus 3x to the 5 minus x to the 6. Add 6x squared minus 12x cubed plus 6x to the 4 plus 12x minus 12x squared plus 8. And there we are. So then if we collect the like terms, well, firstly, let's do x to the 6 here. We just have minus x to the 6. Okay. Then do the x to the 5 terms. Well, it's just 3x to the 5 here. So we can cancel that out. Then x to the 4 minus 3x to the 4. But then we have plus 6x to the 4. So overall that'd be plus 3x to the 4. Right? Minus 3 plus 6 is plus 3. There we are. Then the x cubed term, so if x cubed minus 12x cubed, that'd be minus 11x cubed. Then we have 6x squared minus 12x squared, that'd be minus 6x squared. And then we have 12x. And then we have plus 8 on the end. And there we are. So that is our expansion of that whole bracket. So there. So recognise we use the substitution between 2 plus y cubed to this 2 plus x minus x squared cubed, because they're effectively the same. If I just said y is x minus x squared, the other part, right? And then I just reuse the expansion that I did for y. And then I get this at the very end. Okay, cool. Final part. Fine, I remember. It has to be in ascending powers of x. That means the terms we wrote down have to be in increasing all powers of x. So it needs to go from like x to x squared to x cubed to x to the 4 and so on. We've done the opposite way around, and we started with x to the 6 and we've gone down in powers from 6 to 5 to 4 and so on. So we've gone down, but it needs to go up instead in powers. So we just simply flip the order. So we start from 8 and then plus 12x minus 6x squared minus 11x cubed plus 3x to the 4 plus 3x to the 5 minus x to the 6. And there we are. So that's our actual answer then, in ascending order of x. So again, if you see anything about ascending order of x, it means the powers of x have to go up as you write the terms. So there we are. Cool. Final question then. The coefficient of x cubed, now I should note, this was from the textbook. They actually meant x squared, because their answer is talking about x squared term, okay? So the coefficient of x squared in the expansion of 2 minus x, 3 plus bx cubed is 45. Find the possible values of b here. Okay, so firstly, the coefficient of x squared is 45. That means we need 45x squared, right? That tells us then we need to consider the x squared term of this whole bracket here. Now, that's essentially saying we're timesing them together, right? We can look at this as saying 2 minus x times 3 plus bx cubed, right? Because they're close together. There's a hidden times in, right? Now, actually, we can expand them individually, right? Okay. So firstly, let's expand 3 plus bx cubed. Now that I can, that I'm going to use using Pascal's. So firstly, if I do the first few rows, that'd be 1, 1, 1, 1, and then 2, 1, then 1, and then that'll go to 3 here, 3 here, and then the 1 outside again. And actually that'd be row 3 here. Again, if we start from row 0 at the top, row 1, then row 2, then we get to these numbers, row 3. That's what we're interested in. So there we are. That tells the coefficients of this bracket here. So I'm going to do this individually. So 3 plus bx cubed firstly. Now, why row 3? Again, because we have 3 as the power there. Reminder, the power corresponds to the row we're interested in the triangle. Okay, so then the first term would be x cubed. Well, it won't be just x cubed, it'd be bx cubed because there's a b tagged to it. So it'd be bx all cubed. Then the coefficient, as it's the first term, it'd be a 1. And then we have to include the 3 as well. So then that'd be 3 to the power 0, because obviously 3 and 0 gets us 3 overall. Then the next term would be 3, then coefficient 3 there. And then we have x squared, so going down by power. So bx all squared now. And then 3 then will be a power of 1 to make it 3 overall. Then we have the next term, which should be 3. Then bx will now be a power of 1, because we've gone down from 2 to 1. Then we go from 3, but then that'll be a power of 2, because then 1 and 2 again gets us 3 overall, of a power of 3. And then the last term will be 1 there. And then we have bx to the power of 0 now. And then 3 will be a power of 3 to get us 3 overall as a power. So there we are then. So then we just need to expand these brackets. So firstly, the first term here, well, 3 to the 0 is just 1. So effectively, we just got bx all cubed, which should be b cubed x cubed. Then we have, for the next term, 3 lots of bx all squared times 3. Well, 3 times 3 is 9. So simply we've got 9b squared x squared. And then for the next term here, then we got 3 lots of bx times 3 squared. Well, 3 squared is 9. Then 9 times 3 will be 27. So we've got 27bx. Then the last term is 1 lots of bx to the 0. Now that would all go to 1, right, if it's power 0. So effectively we only got 3 cubed, which would then be 27. There we are. And that's it. So that's our expansion. Now we can substitute that into here, because remember we want to consider this kind of bracket, right, when we multiply it by the other bracket 2 minus x. So we get 2 minus x of 3 plus bx cubed is 2 minus x, and then this expression, b cubed x cubed plus 9b squared x squared at 27bx at 27. Now that looks scary, but we don't need to expand it all, because again it's only talking about a particular term, x squared here. That's what we want. We're interested in this. Okay, so we only want to get the x squared term out of this expansion, right? And we're told it has to be 45, the coefficient overall for x squared. So we need to find the x squared term out of this. Now, at this is a common exam sort of question. Basically, what you need to realise is, if you were to expand this bracket, right, overall, obviously don't do all of it, but imagine if you were, firstly, you'll times 2 by all the terms here. If you times 2 by all the terms in the other bracket, what would be the x squared term if you times everything by 2? Well, it would just be this, right? 9b squared x squared times 2. So that'd be 2 lots of 9b squared x squared. That would give me the x squared term. That'd be the only way I can get x squared out of that, if I times 2 by all the terms here. If I times 2 by b cubed x cubed, that'd still be x cubed. 27bx times 2 would still be x overall. And then 27 times 2 would still be a constant. The only x squared way I'm getting x squared by timesing all the terms in this right bracket by the first term here, 2, is the x squared term. Now, we also then would times minus x by all the terms as well. Remember, that's how we expand brackets. If you need a reminder, even it might seem simple, go back to when I talked about expanding brackets in the first chapter in pure. But anyway, that's what we would do. We would have to times a minus x then by all the terms as well. Now, if I times minus x by all the terms here, which of that would get me x squared? Well, actually, it would not be 9b squared x squared anymore, because if we did 9b squared x squared times minus x, that would be minus 9b squared x cubed, right? Because x times x squared. So we need to account for that, and actually, we would then want to, if we want to get x squared, we would need to times minus x by another x, right? Because x times x would be x squared. So it would be this term that gives me the x squared from this. So then we do add minus x lots of 27bx. And that would give me the x squared part here. Because then if we were to simplify that, well, 2 times 9b squared x squared is 18b squared x squared. And then from this part, that would be minus 27bx squared. So these two together give me the overall x squared term. Those are the only two ways I'm going to get x squared from that expansion. So you can see, without doing the whole expansion, which would be quite lengthy, I can just extract the terms that I want by just thinking about how the powers and how things would multiply together, right? If I think about it, if I were to multiply the brackets term by term or one by one, I can think of it that way, okay? And hopefully you can sort of realise what I did there, but that is a common strategy that they ask for in exams, to pick for a certain term in this way. But you'll pick it up and you become more comfortable with this as you go through the topic. But yeah, so this is all the x squared. These are the x squared terms. So that from this expansion here. Right, now we are told that the coefficient of x squared is actually 45. So we should get 45x squared out of all this. So again, we can then just equate the coefficients, so therefore 18b squared here minus 27b here, that would then have to equal 45. And so therefore at this point, it's just an equation for b squared, for b, right? A quadratic for b. So if I take the 45 to the other side, to solve for b, I get 18b squared, take away 27b, take away 45 equals 0. And so then I'm just going to use the quadratic formula. So b then will be plus 27, take all plus or minus the root of minus 27 squared, take away 4 lots of 18, minus 45 over 2 lots of 18. And so that would get me, b is, I've put that in my calculator, b is 5 over 2, or minus 1. And they're quite nice numbers, so it hints that I've probably done it right. Okay, but there we are. So those are two values, although does it say to, no, it just said find the possible values, is plural. So yeah, those are my two answers then. So there we are. Cool. So yeah. So that is, again, the sort of way we'd be looking at expanding brackets. Now, probably a bit, these examples will be a bit tricky to get head around the first time. We are going to look at better, different, better ways of expanding brackets like that as we go through the chapter. And we will look at more examples like this, so you can really start to understand the type of questions, how we solve them, and you get practice by looking at more examples. Examples like this again, like if you've got given a coefficient of a certain bracket, how do you find that, right? We'll be looking at examples exactly like this. We're doing the same sort of thing throughout this chapter, but we've sort of but that's the idea, right? And Pascal's triangle is a foundation for it, right?